Hello everyone, welcome to the next session of ABAP question answer series. Here we are going to discuss the first question is what is mandatory check for all entries? So the answer is do the initiality check for the table on which for all entries is going to be applied. So answer is initiality check is the mandatory for all entries. Another question, what are optional best practices before using for all entries? So we can delete the adjacent duplicates from the internal table on which we are going to apply the for all entries, right? So before that, we must have to sort that. So sorting and deleting the adjacent duplicates, this can be optional check, optional prerequisite, we can say. Another question, what is the consideration in what is the consideration in case of HANA database and non-HANA database with respect to inner join and foreign entries? So the database over here is the HANA and non-HANA database. For inner join, up to 20 tables after NetWeaver 7.40 is possible. Okay, inner join on up to 20 tables is possible after NetWeaver 7.40. Okay, and because it is possible, we can use in the HANA DB. HANA DB is the performance effective, it's fast, so we can use the inner join over there. There is no problem. For all entries can also be used in case of HANA database, right? But if you have the non-HANA database, it is not recommended to use the inner join in case of more than 2 tables. Okay, and so what is recommended? So we are supposed to use the for all entries concept in case of more than 2 tables. Okay, now what are the different types of internal table? Okay, what are the different types of internal table? This is the question. What are the different types of internal table and what are the basic differences? Okay, so here we are having this comparison over here. Okay, or basic detail maybe we can tell, not differences. Difference questions we have, the difference related question we have in another slides. Okay, so here what are the different types of internal table? We are having 3 types of internal table: standard internal table, sorted internal table, and hashed internal table. So this is the standard internal table. It's suitable for 100 records. By default, it performs sequential search, right? You can use more than 100 records, but the workaround you will have to follow is that first you'll have to sort the internal table and then only will have to put the read with binary search, right? In the sorted internal table, by default data in the internal table will be sorted based upon the key field. Okay, this data gets sorted based upon the key field, right? Obviously on the primary key. This you will have to specify, right? Here you can't use append. Append is not possible over here in this internal sorted internal table. Here it will support only the insert operation, and while searching you don't have to tell explicitly to the system that please use the binary search. Not required. Here we have to mention the binary search. Here in sorted internal table, not required to mention. In hashed internal table, hash key gets determined based on the defined key of the internal table, right? Key will be always unique and searching time will going to be always independent of the number of entries. So this is suitable for large number of records. Okay, and this can be suitable for the medium number of records. Okay, come to the another question. What is primary key and secondary key and how it is defined in different internal tables? Okay, in different internal tables. So here you can see that here the first example I have given of the standard table of. So in case of type standard table of, however, this question is not important from the interview point of view. but from the knowledge point of view, or there can be one question. If suppose if we're going to give the interview at architect level, there can be this important question, but at a fresher level, this you can ignore. Okay, from knowledge point of view, let's discuss this one. So here, like if you want to define the standard table with the two key, primary key and secondary key, you will have to add the addition with non-unique key. And here, so the first addition will be by default primary key, and the second onward addition is going to be the secondary key. Okay, with non-unique key, here the first name and last name, and with non-unique hashed key, here you can see that, right? So this is how we can define the secondary key. First is first with non-unique key or with unique key is always going to be, you know, primary key. Second onwards, it's going to be the secondary key. In the sorted table, type sorted table of ts underscore employee with non-unique key. Here non-unique key or unique key addition both is possible. Okay, so the first one is going to be primary. So everywhere the first, whatever the first addition with the with non-unique key or with unique key is going to be the primary key, and afterwards addition is going to be the secondary key. You can just observe over here, this and this, as well as yeah, this and this is going to be secondary key. And here in the case of hashed key, we have only the primary key over here, right? Only single primary key. Here one important note, if you don't define any key explicitly, then a standard key will be the primary key, right? In a standard table, if you don't define any primary key like this with unique key or with non-unique key, whatever the non-character field you have, the combination of those field is going to be, you know, sorry, non-numeric field, not non-character, non-numeric field. So all the character data type field, that means the non-numeric data type field, that C and DT. If you have some component in the internal table having character, numeric, date and time component, you know, in that case, the combination of those fields by default will be understood as a standard key, and that will behave like a primary key. Fine, hope it's clear. And now the very important interview question over here, what's the difference between a standard table, sorted internal table, and the hashed internal table? I have listed down the difference over here, right? A standard internal table, here we use the syntax type table of or type standard table of, sorted internal table of, type sorted table of, this is the syntax, hashed internal table, type hash table of, right? This is the way in which we define. So with respect to defining, this is the a difference, right? With respect to defining, this is the first difference. Now let's go to the second difference. Okay, with respect to operation, with respect to operation, we have here the differences, right? With respect to operation, indexed based operation can be performed. So what are the indexed based operation? You can use the modify using the index, you can use the delete operation using the index, you can insert using the index. That is possible in the standard internal table, right? It supports the index based operation. In case of sorted internal table, also, you know, see that index based operation can be performed. Here also index based operation is possible, like modify is possible, delete is possible, insert is possible, append is not possible over here. In the you know, here the indexed based operation can be performed, here also can be performed. Here one extra thing, that append is there, append can be done. So here in the third point I have written that one. Okay, here the index based operation is not possible, only key based operation is possible in the hashed internal table. Okay, with respect to operation we have seen. And now with respect to append, append is possible in the standard internal table, right? Append is possible in a standard internal table, right? So just a second, I'm trying to, yeah. So here you can see that, here you can see that the third differences. Append is possible in case of a standard internal table. In case of sorted internal table, append is not possible. Only insert is possible. In case of hashed internal table, no append, no insert is possible. Okay. So in case of record insertion at last, this is the things. Okay. Now binary search. So here, if you want to achieve the binary search in case of sorted internal table, if you want to achieve the binary sort, what you will have to do, you must have to sort. Explicitly, you will have to mention the binary search while reading the internal table in case of sorted internal table. And before binary search, you must have to sort the table. But in case of sorted internal table, because it's already sorted, right? Because it's already sorted, you know, you don't have to use this, you don't have to sort, and by default binary search takes place. You don't need to specify the binary search at last. Okay. In case of hashed internal table, no binary search, no sequential search, nothing is performed. Okay. So the by default behavior over here in case of a standard internal table is the standard, sequential search. And in case of sorted internal table, it is having the by default behavior binary search. And here, no binary search, no sequential search. It's a key based search, right? It generates a key, and based upon the key mapping, it does the searching. That's why the hashed internal table is independent of the number of records. The time taken by the hash internal table when we search any record in this hash internal table, that is going to be, the time taken is going to be independent of the number of records, because it search based upon the, you know, the key which is generated by the hash algorithm. Okay, that is the combination of that key generated with the help of the you know, the key defined in the hash internal table. You can see that whenever we define any hash internal table, you must have to define the unique key. You must have to define a with unique key addition over here. This is what you will have to do, then only the hash internal table is possible. Okay. Now the another question, what are the different modularization techniques and why modularization is benefit? Okay. So we have the include program concept, we have the subroutine or procedure concept. Subroutine or procedure, just these are two different names, but the meaning is same. Okay. And here we are having the function module. So three things: include, program, function module, and the sub routine. These are the generally which use for the modularization technique. In object oriented world, we are having the method concept, we have the class concept for the modularization, right? So that can also be included. But the benefit: readability, of course, reusability, and then the maintainability. These are the three benefit we are having. With this, let's stop our today's session, and we will meet tomorrow with a new questions answer. Thank you very much for watching this video. Okay.